In our third demonstration, we will show the use of GRE or VXLAN as an overlay technology to support tenant network virtualization. Here, OpenStack will establish tunnels between compute nodes as the tenant's L2 network, and then L3 subnets will be built on top of those tunnels. Through the F5 LBaaS plugin, the ADC will correctly join the tunnel mesh with the other compute nodes in the overlay network, and then will allocate any IP addresses it needs to perform its services. Here you see the SDN gateway capabilities really coming to light. The VIP in our load balancing as a service could be placed on any kind of network, including a provider's shared VLAN or even a tenant VLAN, while the pool members can exist on one or multiple GRE or VXLAN tunnel networks. All right, welcome back. Third demo. And you'll notice here's my services. I'm at 2. I've got 2 of my VIPs defined. My agent's successfully reporting that back. Now, this time, what we're going to do is we're going to use the same external provider subnet. We're treating it like it's the internet, and we can get to it. We can route right to it. That's why I've been able to go right to my browser and show you screens like this. But this time, we're going to create a VIP, and it's going to create a pool that needs to encompass 2 different tenant GRE overlays networks. So we could do the same thing with VXLAN. The Big IP supports both Open vSwitch compliant GRE and VXLANs. We're going to create a pool that talks to 2 different overlay tunnel networks and the subnets associated with those. Again, I'm not going to make you live through typing all that into Horizon, but I do want to take a second and show you what they look like. Here's a tunnel network for a tenant, and there's the subnet. Again, I can edit all this. I could have added another one. I could have added a third one, a fourth one, a fifth one. These are all virtual networks over a GRE tunnel SDN. Go back to load balancers. I'm going to go back to my little DevOps, happy little DevOps client. I'm going to say go ahead and create that for me. And let's see what it did. Okay, there's my third one down here. And again, there's my VIP. My VIP this time, 110.62. Oh, nope, that's my last one. Sorry about that. A little confused myself. The tunnel, there's the one. 10.062.120. I can cheat real quick and just show it to you. Does it work? Oh, it does, and notice I'm talking to a tunnel network. So we're pretty sure it worked. If you look at what our agent said, it said, hey, yes, you've created a third service. Let's look what this one did on the Big IP. There's my third service for 110. I see the pool associated with it. I go to my pool members. Now notice they're decorated again, but look at the address, subnet space, 172.16 and 17. If I look at my networks down here and I look at my self IPs, yes, I have self IPs, but you'll see they've been generated on GRE tunnels. Did I create the GRE tunnels? Really? Yes, we did. So what this means is that the Big IP actually entered into a GRE tunnel mesh with the appropriate OpenStack compute nodes running their Open vSwitch. We support ML2 L2 populate as well, which means we can keep the tunnel mesh just down to the appropriate compute nodes that we need to build the overlay mesh network with. We also do some very cool things, like we automatically, because we know where these pool members were, we automatically populate their MAC addresses to the appropriate VTEP and put in static ARP entries, so we don't need to broadcast across the tunnels. All that work's done. We've built the layer 2, we've built the layer 3. And again, we can see that the pool members are all up. We're communicating well with all those, and in fact, like we showed, here I am, talking to a tunnel network. So there's our third demonstration. This time it was a VIP on a subnet on a provider, a VLAN, to a pool which encompassed 2 different SDN overlay networks with 2 different subnets defined for each one of those networks in my network virtualization cloud. That would be demo 3.